All I care about is, can we figure out if it's even or odd? I don't care about the actual value. So how would you calculate if that's even or odd? I'm sorry?
If it has any even numbers in it.
That's going to become very... I mean, all of them are going to have even numbers, unfortunately. And it's going to depend on rows. But remember, what we need to do is we need to calculate all of these values in an entire level of Pascal's triangle. What we can do is we can relate this value to the immediately preceding value. So let's look at n choose k plus 1. This is n factorial over k plus 1 factorial n minus k plus 1 factorial. I want to express this in terms of n factorial, k factorial, n minus k factorial. Well, the k plus 1 factorial, it's screaming to me what I should do. I should pull out a k plus 1. And so I'll have an n factorial, I'll have a k factorial, and I'll put a k plus 1 over here. Now this is n minus k minus 1. I want to have n minus k. So I need to put in an n minus k down below. And now up above, I will have a n minus k. So what we get is n choose k plus 1 is n choose k, n minus k over k plus 1. So if I know this value, I can get the next value very quickly by just looking at, am I multiplying by an even or an odd number? Can I use this to march all the way down? So is this always going to be an even or an odd number? So you're shaking your head, so why is it not always going to be an even or an odd number?
What if you have a fraction?
Yeah, I could have a fraction. So I can't do anything as simple as just saying, multiply this by an even number. If it's even, okay, now I have an even number. If it's odd, I don't change parity. If that was the case, once I put in an even number, I'd be even for all eternity. So the difficulty is this is a fraction at times. In fact, it's almost always a fraction. So if I want to do something like this, I have to store this value. And then I have to do some divisions as I go down. So you now have trade-offs. And it's not immediately clear which is better. Is it better to keep the running values of these and have basically no memory issues? Or is it better to save that last previous level and then use the fundamental property of Pascal's triangle that you add things? So if anybody's interested in trying to take a turn at computer programming, this is a great thing to try. Which allows you to construct Pascal's triangle mod 2 faster? Which is more expensive, putting things in memory and calling them out, or keeping track of very large numbers, and then having to do some divisions? So this is, I think, a good place to end the Pascal's triangle lecture. But again, this is a very parallelizable process. I guess I probably should end on that. How would you parallelize that? Well, we talked one way is, we had the breaks like this, and this triangle was the same as this one and this one. So one way to parallelize is, I don't really have to do this, I can do this in copy. To me, that's not really parallelizing. That's just, cleverly noticing that this is the same as this is the same as this. How else could you parallelize Pascal's triangle?
If you're doing the way where you just store the previous one in that same column,
right?
Then you can break it up by columns because you don't rely on the previous row.
Okay.
Or the previous column.
So good. So what we could do is I could have one person calculate this and another person calculate this. And in fact, you can do this directly. We could use this formula over here so we don't know the previous. So we could start here. And then once we have this, now we can fill in and keep going. So different people could start at different places. It's a little bit sad to start here because you don't have the previous. So you would have to use a trick like this for that first initial level. But then once you have that, then if knowing the previous level was better, then you could keep doing that. Who do you think should have to do more levels? Person 1 or person 2? Yeah, person 1 clearly needs to do more levels, because their levels are going to be smaller, they'll be faster to compute. And so depending on how many people you have, you would adjust how much computation you want them to do, and you would not assign them an equal number of levels, you would try to break the computation into an equal number of steps or operations. So again, it sometimes becomes a bit of a pain to dynamically manage something like this, but what you can see is the interplay between the different techniques. Sometimes I have one method that works really well in one environment, sometimes I have another method that works really well in another. How can I combine them and get something that's even better? And how can I minimize the different demands? What kind of issues do I have on my system? Okay. The last thing I wanted to talk about for the mathematics was sorting algorithms. How many of you have done any computer science where you've done quick sort, bubble sort, merge sort, all that stuff? How many of you remember how you hand in exams in my classes? How did I have you guys hand in exams?
Alphabetically.
Yeah. In what way? It depends on how much of what kind of mood I'm in. I have usually two different alphabetical ways that I would have people hand in exams. Do you remember? One way is I would break the alphabet up into like 4 or 5 groups and say just put your name, your exam in the appropriate group, A through E, F through whatever, something like that. Or I would just have one massive pile, and I'm just not feeling, generous. Just put your exam in alphabetically relative to everyone else, and just have each person individually doing it. Okay? The reason I was doing this is because I knew someday I would be teaching a LEGO 1 to Study course, and I wanted to have that as a possibility. So here's 2 methods. Method 1, method 2. So, place in order as you go. Put in piles and merge. So in the pile 1, I then have to sort each pile, and then I merge the piles. Okay? So here, I might have A through E, F through L, M through R, S through Z. Which way do you think is better? And better, of course, is better for me, right? Method 1, right? There's a inequality between me and you, right? If I say which is better for me, method 1 is better, because at the end of the day, everything is done. Which is better for the world if we are all considered equal? Probably method 2. So it's, where do you want the extra work to be done? Right? There's a certain amount of work that has to be done. So this leads to sorting, it leads to queuing theory. There's a lot of great mathematics behind issues like this. So let's try to figure out how expensive is something like this. How many operations are being done? So as you're going through, what's the worst case that could happen as you're going through here? How many steps could it take? Let's say we have 20 people.
19 factorial.
Hopefully it's not as bad as 19 factorial. If it's 19 factorial is so astronomically large that I would never be able to grade exams. And I have a history of getting exams back quickly. Right? I would be in real danger. I'm sorry?
Get it back quickly because you have your students sort them for you.
But they'd have to be able to sort them.
It'd just be the sum of like 20 plus 19 all the way down.
Ah, good. Why would that be it?
Because first person puts it in, second person could
Right.
have 2 steps.
So worst case, first person comes in here. Then the worst case would be the second person is right after the first person, so they have to rifle through all the papers. Then the third person keeps looking and comes down here. Remember, we're just being very naive and just going through like this. We're not doing anything fast, like looking halfway through. Okay. So we just go very naively. Then the fourth person comes here, fifth person, all the way to the 20th. So the cost is 1 plus 2 plus 20, or in general, 1 plus 2 plus n, which not coincidentally, we saw yesterday, and sums to n plus 1 over 2. So that's how expensive this could be. What about this system? So I've now broken it up into 4 pieces. So how many steps could this take? Well, let's look at each block. And we will assume that I have chosen my students well, so that 25% of my students land here, 25 here, 25 here, 25 here. Right? That's not hard to do. I have a class list, and I can just choose these letters based on my class list. Right? So I've got 5 people in each of these. How many steps could it cost to sort the 5 people in here?
5 plus 4 plus 3 plus 2 plus 1.
Right. Could be 1, 2, 3, 4, 5 again. And so, how much does that add up to? 60 total. So this is 60 steps. And over here, we should actually put this in 20 times 21 over 2. 20 over 2 is 10, 210.
So for method 2, are we only counting your steps?
I'm sorry?
We're not counting the student steps where they figure out which pile they go in?
We'll assume the students immediately can know which pile they go into. But then when they're putting them in the pile, it will take 15 steps, worst case scenario, for all of these. When you're doing analyses like these, you have to be very careful. Are you doing worst case scenario, best case scenario, average? And so when you're comparing the different methods, it's actually very tricky, because there are some methods which most of the time are better, but sometimes are really bad. So frequently what you'll do is you'll run the really good method, and if it doesn't finish quickly, you'll throw it away and then go to something else. And frequently that's a very efficient way to do things. Try to do the really fast method. If it doesn't break down, great. If it's not, if it's hanging up, if it's taking too long, ditch it and go on to the next. Alright, so it takes me 60 steps to get to these 5 sorted boxes. Alright? And so again, in this scenario, my students are just putting their exams down. They're not even putting them in alphabetical order within the boxes. Sometimes I make them do that. Depends on the mood. How many steps does it take now to finish sorting these? I've got 5 boxes that are now in alphabetical order, and I want to combine them. So if you've seen something like this before, don't speak up. So I want to somehow combine them. How should I combine them?
You just like stack them on top of each other.
Okay, and how will that help?
So you get A through Z, so you should put the first pile on, like S through Z goes on the bottom, then M through R, then F through L, then A through E. Is that what you mean?
Oh, yeah, so that's right. So in this case, sorry, this is going to be very easy. Yes, you're right. Sorry. At this point, yes, it's very easy, so we're done. Because they've already been put into the correct boxes alphabetically. Yes, I'm sorry. This is very straightforward now for me to fix. So all I have to do is just fix these, and then boom, 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 and it's not so bad. That's much better than having people come in the unordered boxes. But this does require people to understand the alphabet. Okay? I was a graduate student at Princeton. One of my jobs is I was the social chair at the graduate college. I was in charge of managing the VHS database and collection, which eventually did become DVDs, but we had students filing their movies when they were done. It's amazing how many times we posted and in how many places we posted what the alphabet was. And it helped somewhat. But there was a lot of trouble with people putting movies, and we were fine if you just put it somewhere in the S's, that's okay. We don't mind where Star Trek and Star Wars fall relative to each other, just have them in the S's. But let's take something a little bit harder. Let's assume the students just randomly put them in 5 boxes. In 4 boxes. So now they're not labeled. So now the students put them into 4 boxes, and I can sort the 4 boxes in 60 steps. But now, sadly, I'm not done. I have to somehow merge the boxes, and this is why this method is called merge sort. So there's a couple of ways to do it. Can somebody give me one way to try to merge them? Yes.
You could start with just pick the first paper off the first pile, and then look at the next 3 piles and see if there's one that's next to it that's not the next alphabet that's
Okay.
in your pile. So you
That's one way to do it, is to pick up something from here and then look at all the remaining 3. How else could I do it?
You could break up the alphabet into a bunch of different letters, and in each individual box, take the papers that fit each category out, and then combine all the categories, or combine each category together for all 4 boxes. Does that make sense?
Right, but then you're going to be separating this into